In today's lesson, we are going to talk about hyperbolas. So it is our next conic section that we'll be graphing, and I'm going to give you the equations. So we have the horizontal and the vertical, similar to parabolas. So the first one, x minus h squared minus y minus k squared. So having that subtraction is new. Our other ones were all addition. And then over a squared over b squared equals 1. And then the vertical one, y minus k squared minus x minus h squared over a squared over b squared equals 1. So when we were working with ellipses, a was the bigger denominator, but in this one, a is first. So biggest difference here, if you have minus the y versus minus the x. Or you could think if the x is positive, there's your horizontal. If the y is positive, there's your vertical. Okay, so what does a hyperbola look like? So I'm just going to draw a generic one. There's this center, and then there are vertices. And then I have what we'll call co-vertices, but they're not actual points on the graph. They're just going to guide us. Using those co-vertices, we can draw this box, and then the diagonals of this box create these oblique asymptotes. And then what we have is here are vertices, and then they follow, our graph follows those oblique asymptotes. And then just like our other conic sections, we have foci. All right, so center is HK, vertices when we're horizontal, that would be your H plus and minus A, K. And then your co-vertices will be H and then K plus and minus B. Your foci, similar to ellipses, we use this formula to find that C value, and the C value will tell you how far away from the vertices. This time it's a squared plus b squared equals c squared, and we'll find C. The transverse axis and conjugate axis, we don't actually need to draw. Think of this as the axis of symmetry. So y equals k, that's like your axis of symmetry, and then the conjugate axis, x equals h, is there. And then for the vertical one, same idea. So I've got the center, and the vertices are up and down, so the co-vertices will be left and right, and we're going to use those to draw this box. So the diagonals can make those oblique asymptotes. And then a quick sketch. Center HK. To find the foci, same thing, is the c squared equals a squared plus b squared. Vertices are going up and down, so we have h, k plus or minus a, and the co-vertices are h plus and minus b, k. And then these ones switch. The transverse axis is the vertical one, so x equals h, conjugate axis, y equals k. Okay, so let's actually graph one. Y squared over 9 minus x squared over 25 equals 1. So starting out, because the y squared is positive, it's going to be a vertical hyperbola. And on this one, the center is at 0, 0. So whichever one is first is where you get your vertices from. So from the center, we're going to go up 3 and down 3. And then the second term will give us our covertices. So I'm going to go left and right 5. So now we're going to use vertices and covertices to just sketch this little box. Because the diagonals of this box give us our oblique asymptotes. And now to finish graphing, we can make an XY table and get some more exact points, but really we have these asymptotes that help guide where our graph goes. And as long as we've got our curve that follows the asymptotes, we'll have a pretty good sketch of the hyperbola. So we now just need to get the foci on there. So c squared equals 9 plus 25. So c will be the square root of 34, which is about 5.8. So from the center, we're going to move up and down 5.8. 1, 2, 3, 4, 5.8. And there we have your full graph of the hyperbola. All right, here is another example. This time, that leading term that's positive is x, so there'll be a horizontal parabola. And this time it's not centered at 0, 0, so it's centered at -1, -2. Okay, the first term tells you how to get your vertices. So because it's under the x, our vertices are left and right. And then the second, this will get us our covertices. So I'm going to go up 4 and down 4. Sketch the box. And then oblique asymptotes. And then use those to sketch the hyperbola. And last step, find the foci. So c squared equals 9 plus 16. Well, that will be 25. So c is plus and minus 5. And then you're done. So not too bad. So now last step is getting them into this form. All right, so here we have an equation that we want to get into that standard form of a hyperbola. So we know it's going to be a hyperbola because one of our squared terms is negative. So let's group our x's and y's together. So 25x squared plus 100x, parentheses, I'm going to leave a space. And then I'm going to write this as plus, but then in parentheses do my negative 16y squared plus 96y, leave a space, equals 444. All right, so leading coefficients need to be factored out. So 25x squared plus 4x, still have my space. We'll take out the negative 16, so we have y squared, and then we have minus 6y. Now we can do our b divided by 2 squared step. So 4 divided by 2 squared, so I've got 4, but because I'm adding 4 to balance it out, I actually have to add 100. And then over here, the b divided by 2 squared, I'm going to add 9, but technically that would be a negative 144. So we'll have to combine these and then factor these. All right, so 25, and then this goes down to x plus 2 squared minus 16, y minus 3 squared. And then this should equal 400. All right, remember we want this to be equal to 1, so we can now divide all terms by 400, and then we can simplify these. This will leave us with x plus 2 squared over 16 minus y minus 3 squared over 25 equals 1. And now let's put it on the graph. We have the center at negative 2, 3. Let's see, vertices left and right 4. Co-vertices up and down 5. Sketch the box. Get your asymptotes on there. And sketch your hyperbola. And then last step, get the foci. So c squared equals 16 plus 25. So c will be the square root of 41, which is about 6.4. And there is your full video on hyperbolas. Good luck with the lesson.